retro spectrum coders. This is a bonus stream, a bonus late night coding session. I've been asked to take a second look at the original series I did where I was drawing sprites rather than UDGs. We're still at the beginner level on that series, and we're using UDG 8x8 sprites, and we've just learned how to colour the background to one solid colour, and we'll be quickly moving past that, but we're going to add some collision detection and stuff like that into that project. This project was abandoned because it was a little bit too fast for my taste for the channel, but there has been interest, and this would sort of complete what I've done so far by including colours with the sprites. I have it working here at my end, but I'm not going to just load that up and show you it because that's not how it's going to work. It's not going to really be fun to learn from that. That said, it is available on GitHub, and there'll be links in the description. If there happens to not be one, I haven't filled it in, go and look at some other videos, you're bound to find the link eventually. And again, it's a late night session here, so my voice might be a bit different. I can't speak too loud, but other than that, yeah, we're ready to go. What we've done is we've got a blank page, and if you look at here, I've made a new folder called Specky Colors. That's the name of this project. In that, I've already imported or copy and pasted my utility folder, my util folder that we created before, which I'll show you in a minute. I've also behind the scenes created a folder called a file called bitmaps. That's just got a really shoddy bitmap in it, which is a face which is 16 by 16 pixels. Because obviously you don't want to sit and watch me draw a stupid face for 10 minutes. And of course I've got this blank file, speckycolors.asm. So that's what you're going to need. And I'm going to load up that util folder now. Right, first the easy one. So you've seen the folder structure, and if you get stuck and things aren't working for whatever reason when you try and compile, make sure everything matches that. I know most of you watching this series, you know how to do all this anyway, but just in case there's a beginner who doesn't know that, give me a second. Alright, yeah, so this is bitmap 1, and that's our sprite, and it's in the file bitmaps.asm. And as you can see, if I highlight a 1, there we go, he's a bit of a Bart Simpson. He's like a spectrum version of Bart Simpson. Alright, he's got the spiky hair, little grin and a nose, and he's going to be painted yellow. The rest of the background we're going to look at another time. We are going to obviously paint a background here to demonstrate, but we'll later learn very soon in this series how to use a tile map or come up with some sort of algorithm to make a basic like scene. I'm not talking about a tiled map with more than the screen size. We're just going to tile the screen, but yeah, I'm just getting sidetracked because we're not doing that right now. That's next time. But yeah, we've got this Bart Simpson guy. That's bitmaps, easy peasy. Collection of bitmaps. YX to pix. You should have known this from my other videos. Here it is, so you can copy it down if you haven't already got a copy. Just look at YX to pix, don't worry about the rest right now. Of course, if you haven't got this already written down and you're following like right now, you're just going to have to pause it Can't sit here too long looking at these. But we used these in every video where we drew sprites, and even did we use it in the other one with UDGs? We might well have done. But of course what it's doing is it's moving bits around into the set way so that they line up with the spectrum memory, and then you end up with a memory address. That is a whole lesson and a half on its own. So just use it and read the comments. Eventually you'll learn how it works, you'll understand it. And the beauty of it is you don't need to right now, but it works in conjunction with this, which checks, it moves down a line, and also checks whether you're crossing a character cell. Anyway, that's enough of screen tools. So you've got bitmaps and screen tools. Screen tools is inside util. So in our blank folder, our file, we create a constant entry point like we always do. And this memory address here is going to be fine, 32768, or entry point. I'm going to, end entry point. That's going to be the end of our program. I'm going to stop there for a second because I remember something else I did behind the scenes. That's the only add-on extension that I'm using now. Obviously that as well, but this one's relative to what we're doing, or relevant I should say. And I did have some other ones installed, so I ended up with this one. Anyway, one of the other ones is potentially better, but I found I can't remember what problem I ran into and it made me change. It was something minor, but I just thought I'd let you know that in case you wondered why colours might have changed. Anyway, I'm getting sidetracked. So we've got our program entry point. That's our complete program space. First thing we need to do is just like what we've seen before, OXDAF. Clears the screen and open channel 2. So far in all my programs I've done that once right at the start of every program and that's it, but I expect when you get into a higher level of programming, you know, when you've got lots of scenes, you might want to do it more often, but I haven't needed to, and I've got games that change scene. The next thing I want to do is demonstrate how simple drawing colours is compared to drawing sprites. So we're just going to paint the background. Every cell is going to just be assigned a random colour, right? Now for that I need the random number generator function, which I'm just going to copy and paste in. We've written it enough times. I actually have this normally in a tools file, but I didn't want to import that because I didn't want to confuse the issue. But here it is. So I'll just paste it in, 7, 8 lines, 10 lines max. It's a function or a routine or whatever you want to call it, called getRand. And what I haven't put in the notes is it sets A to a random number. Alright, I've been abbreviating the word random number to rand for like multiple years, so that just means random number to me. Okay, so we got that can just stay right down there. Oh, we do need a seed. Just declare seed because I've used it here. It's a 2-byte word, not a byte, and it can become zero, start at 0. Now look, you're gonna have to watch my other videos if you don't understand that. Where were we? As a demonstration, right at the beginning of the program, we're just going to paint a background of random colours, like I said. So I don't need to comment it. This is just for for our own purposes. We're going to load BC with the attribute memory start, and I'm going to create a constant so that it keeps it nice and easy. We'll end up with another folder for I keep calling them folders, I don't know why. Another file just for constants, but not this time. So that's the mem start, and that position, that number there, is our start of our attribute memory. Excuse me. While we're here, we want attribute mem end. That's where the memory ends. However, we want to be able to check that in an 8-bit register. That is a 16-bit number. So we'll name it correctly. And we'll call it the upper byte. And I think that's 5B on the top of my head, but I will check that now. Yes, it is. So when we reach 5B, we know we've finished. That's for the purposes of looping and ending the loop. So now we've written those, we can do that. We'll call our loop random background. Call get rand. So A equals rand. We're going to mask it because we only want to deal with the paper. And it goes flash brightness 3 for paper, 3 for ink, and you've got 1 byte. That represents a whole character cell in the colours of it. We won't talk about flash and bright right now, you can ignore those. They're really simple. Again, check my other videos, there's reading there. Just for completion purposes, because this is going to end up on GitHub, I'll pop that there as a note. And I will comment draw. I like to call it paint for some reason when I'm dealing with attributes. I've just got into the habit of calling it painting. Paint random colours to each cell in paper only. So that's the bit I was trying to get at. We're doing paper only. So we need the AND bitwise operation. The first colours we want 0. I mean the first bits, or the 7th and 6th bit, because that's the flash and that. Now when I was testing this out earlier, obviously the first thing I did was do that, and that means that now we're only going to get, all of them are going to be 0, and these will be 1 if they happen to be 1 in the random number as well. So we would get a random colour of all kinds of colours. But what happened was I specified the player sprite to be yellow, and we got a lot of yellow drawn as background, so it kind of looked rubbish. So I decided just to mask out yellow, which left us with just a few colours choice. Is that 4 colours rather than 7? Anyway, this is just for a load of rubbish fun anyway. So the next thing we do is we've got BCs, we've got a pointer to our memory address, the first cell. So we're going to draw to it the actual data now, hence the brackets, with A, because A's already just been, it's become a random number. We've masked it, so it can only be one of those, which, you know, I'm not going to work out what it is, decimal. You get the picture with that now. After that, we'll increase the pointer. So maybe I should comment this. Mask out all but some paper colours. That'll do. Load attribute memory address with color byte, or attribute byte I should probably say. Increment pointer. So it's really that straightforward, because we don't care about what colors come in next. We're just going to go through every cell one by one, and that's what I wanted to point out by doing this. I'm going to slow the loop down so we can see each one being drawn in order. What I do want to do, I don't think we'll have time at the end, but we might, is draw each pixel instead. Like for the sprite purposes, you need to draw pixels, and you'll notice it does not go in the order you'd expect, but this one will. See, this can be treated like a 1D array, which is why we're just incrementing the pointer. Now A's finished with, we can load A with the attribute upper byte, use it to compare to B. So if the upper byte of BC equals what our constant is for this, so if the upper byte only is equal to that, we compare that there. If it's not equal, we jump back. So we don't need a return statement, because this is not actually like a routine that's been separated. It's in line, so it will run straight into, well, we haven't got a main function. It's going to jump straight into there afterwards. Now this is not ideal. It's faster, but we could create a function to do it, and then we could redo it next level. It could be a different random bunch of squares. Do you see what I mean? But you'd have to write all that code again. It's in line. So after it runs out, and after that is equal to that, we're not going to draw anything else or loop back. We're just going to go straight to main and stay there. And that's going to work for us, isn't it? So I'm going to quickly recap over this in case I don't think anyone's watching live. Oh, hello Moz. Sorry I didn't notice your message, mate. I was in full flow there. No worries, mate. No worries. I'll keep an eye out for the messages now. I'll move that over. Nice one. You're still there. Good stuff. Yeah. Do you want me to like browse through the code slowly so you can copy it down? Or you're happy just watching for now? No worries. What we're about to do now actually is just run it, because it should just draw a load of random colours for us. That's good. That's good. You can always be able to watch it back on YouTube, as you probably know. Right, so I think that's self-explanatory to everyone watching this, but I'm compiling this file into a file called s.tap, and it's compiled successfully. And then II is invoke item s.tap, and there we go. We've got our bunch of random squares, and it drew really quickly, as you might have noticed. Like, you probably didn't even notice, it just came straight up. But I couldn't see it was actually blocked by my microphone, so I had to wait a few seconds before I'd seen it. What I noticed when I was testing this earlier is that's not random, because it happens at the same time every single time we call the program. It's always the same. That's irrelevant to this topic, but it's a side issue just, to deal with. But it doesn't look nice, but that's just to demonstrate the colours, okay, and the cells. And if I just move that over, if I put like even just 3 halts here, so I've slowed it down to 17 frames per second now. And as you can see, all we're doing, literally that simple. And I've seen so many examples where it's not this simple. Like, I've simplified this. I'm not trying to blow my own trumpet. I'll probably get someone hating on me for saying it, but every example I've ever read or watched is so overblown. This one is not. But the memory starts at 0x5 yeah, there. 58,000 hex, or 5800 hex. That's obviously a 16-bit number. All we do is get that random number, mask it so that it can only be a 0 and 1 there, everywhere else is 0, and poke it into that memory address. It's that straightforward. Then we increment the pointer. This is a separate sort of issue where we're just loading A with the upper side of the memory, 5B, the upper byte. And if it happens to equal that, then we get out of there. And if not, that's the N, not equal, bang, go back. So it just goes up 1, 2, 3, 4 through the memory. And as you'll see in a second, it comes out in the exact order you would expect. And there we go. So that's the order everyone works with array, in your head. That's how it works. But if you look at doing pixels, which maybe I should do now, but I haven't actually done this behind the scenes. The pixels will draw like this, bang, and then skip to here, bang, and skip to here, bang, and then all the way to the bottom, and then they'll go to the second line, bang, bang, and you've got to calculate that, and that's what all this is doing, so that you don't have to worry about that. And same as me, I've actually had a lot of help writing that code that I now just use. I mean, I do know what every instruction does, but I don't think I could just delete that and rewrite it, Anyway, so we've done that. Our next bit is mega boring because what I chose to do for my new game is from advice from a lot of people. One sec. So my chat window is small because I'm running with not a massive screen space. They don't make colours like that anymore. Yeah, I agree. They use decimal when it really makes sense just to use the binary, you know, and everyone will understand it now. I agree. So that's what spurred me on to make these videos, to be honest, mate. When I started to get the hang of it, and I mean, it's a lot harder when you press that go live button and try and do some coding. Like when you're on your own, trust me, it's a lot easier. You know, I get a lot more production, it's a lot more productive. But you know, I just thought to myself, I don't think I can do better. Trust me, I'm not trying to say that, but I think I can do better for a beginner. You know, that's what I'm thinking. There's not that much available for a beginner. I know not that many people are interested in this topic, but over the years, there's bound to be a few. I think we're settled with our background. I mean, I could set it so it's just all one color now, you know, just get rid of this and change it to a color. And we could even go through the hassle of changing each level, you know, wait until a number is a certain number and change the color. But that's going to really just ruin the lesson, in my opinion. We're going to make do with this random background. That's going to be the background of our game. It's not even a game we're doing here. It's like a demo, a really bad demo. We've already got our bitmap here that I've created. You can go ahead and create your own. Just do it all once if you can't be bothered. Don't get sidetracked. Yeah, as I was saying, this time round, on the advice of a lot of people who have a lot of knowledge that I've spoke to online through forums, they say I should be going more specific rather than writing all these complicated loops, which I'm actually in favour of because it's easier, but it is more time consuming and more boring because you copy and paste a lot more. Basically, long story short, I've written a draw player sprite function that works the exact same way as my other one, but it only does 16 by 16. I'm kind of thinking I should just paste it in here. It's a lot of lines. If I type it, it could take a long time. Do you know what? I should type it, shouldn't I? Yeah, let's type it. Right, so this one does have inputs, which are HL being the bitmap pointer. We're familiar with that. I think we used IX last time. Alright, well, I've used a variable, for want of a better word, or a property, and I haven't created it, so let's create it. I tend to keep my data at the bottom because I did try putting some to the top on a fresh project and did run into some problems with includes and constant, and to be honest, it does seem to work better at the bottom. So I'll put my usual little divider there. X, D, 8, Y. The only reason I'm starting it at 8 is because I just didn't want it to start at the top corner. And 8 is the size of a character cell. There is a limitation with this function where it doesn't always get colour right. You'll see in a bit. Oh. Is there any more we need while we're down here? Don't think so. Not right now. Okay, so a lot of this is self-explanatory, but if I go too fast, please tell me. But there's a lot to get through here. I will stop and pause if I see something that's worth explaining. I mean, like this, for example. What we've done there is I've just loaded BC with YX, and that's how that function works. You will have used that by now. If not, there are some other videos to help you. I'm going to be a bit more sparing with my comments. But sometimes, like this, it does really help me to comment it, because I'm going to be copy and pasting this. We're doing the first line of the bitmap, and we're going to actually do it one by one. What I should probably write here, actually. Specific 16 by 16 sprite only. Yeah, that'll do. So we're doing the first line. As I say, HL is the bitmap pointer. We're taking the data from the pointer and popping it into A. Just trying to work out what I'm doing there myself. Oh, of course, we're just putting that into the actual screen memory, which YX picks popped into the right address for us. Might as well make it super clear and put that as a pointer. No, that's wrong, sorry. We're using the same thing we just saw a minute ago, where we're incrementing the pointers. However, what I've done here is I've incremented the pointer for our bitmap so that we've moved on to this byte now. But for the DE pointer, I only wanted to increment it DE once. And that's because I'm going right one time. I don't know if you can do increment DE. Let me have a look. I'm sure you can actually. And that might have worked just as well. I think the only reason I went for the other one was because it actually uses slightly less processor when I looked it up. Anyway, let's now get sidetracked. My internet's not loading that fast. So I hope you see what's happened there. Because we're basically going to copy and paste this in a minute, over and over again. Let me try and comment some of this. Take first byte. Well, no, because I'm going to copy and paste it. I don't want to change it. Take byte from bitmap pointer. Load it at where DE points to. Increment bitmap to next byte. Move screen attribute. Oh, hang on, we're drawing here, not screen attribute. Move screen address right 1 pixel. Let me make sure I don't mess up here because I'm copying my work here. because it's quite in depth. I did have to do some trial and error on getting this one right. Well, not trial and error, that's the wrong one. Some messing about. I wonder if I could word that better. In my notes I put set byte 1 before. Load A with the data. Again, we're doing the same thing, but we've moved the long 1. Do I need to comment that? No, I don't. So obviously byte 1 is your upper left, your origin. Byte 2 is the one next to it. So there's byte 1, there's byte 2. Yeah. Now we need to decrease or decrement E, because we just moved it along 1, and then we're going to decrement it and move it down the whole line. Not really worth commenting. Well, yeah. Okay. Nah, I can't really comment that easily. But basically, we call next line down, which is this little bugger. Can't explain off the top of my head how that one works either. I did write it myself, but a few weeks ago. It moves down a line for DE, but it does what it says in the comment. That's all we have to do, and then we just have to copy that have 16 of those. Just let me make sure. Yeah. So 2. Two, 3. Oh look, it's done that to me before. It doesn't copy the comment. You've got to be very careful with this. That's 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's laborious, but apparently this will run quite a bit faster than my code before. Luckily, I'm just changing comments. I don't think you even have to. You didn't want to. I don't think there's anything I need to change there. The code just works. Right at the bottom there is. We don't need to do any of that. What is this? Is this a function, isn't it? So return. So as I say, it was a lot of code, but most of it was copy pasta. That's the main juice of it, which obviously includes that. That's the real muscle there, and obviously that's the bit that is still hard for me to understand. But as I say, don't need to. When you sit there and think about it long enough, you do end up understanding it. But whether you could write it yourself from scratch is another matter. So that will draw the player, but we need to go through the same rigmarole to delete it. The only difference being is we don't need to load A with the bitmap. We just X or A. X or A means make A 0. Should I just copy and paste it? I think I will. And I can just show you it. Because this is just to move the player around. We don't want to spend too long on that. We've already done it. Okay, so there's the draw function. I've just pasted all this in. It's almost the same. It's called delete player. I'm not even going to comment it. As I said, the only difference is every time you load A with HL, HL isn't needed in this function, not as an input. Oh, wait there. Not even sure why I'm doing all these inc HLs. I don't think they're needed. Pretty sure we could safely delete them, but just leave them there. It works in my code that I've tested. You can obviously, if you're writing this at home, try commenting them out, all the inc HLs. I might try it later, but let's get this thing running. I'm copy and pasting again because I don't want to sit here and show you yet again how to make a moving sprite and stuff. We've done that. So between the draw and the delete, because they look a bit similar, I decided I'd pop the move code to split them up so I knew which one I was dealing with. Oh, hang on. Yeah, move player. So these have been commented out intentionally for other keys that could do something in a game. But so far we've got WASD movement set up, and that's from another lesson as well. We're getting near to the point where we just need to load into main. Where have I put main? Sugar. I've blocked main. Like main at the top. After the background. So it runs straight in there because I forgot about that. We didn't make a function, it's in line. I've lost track of what I'm doing again. I do apologise. Wait a second. Oh yeah, we're just going to try it. I think we're ready. Just to get the moving sprite. No colours yet. I'll put my customary halt at the start. It's now 50 FPS. I'm loading the pointer into HL as the inputs describe. I don't think it's needed in delete player. We can address that later though. For some reason in my code earlier I did it. I mean I was getting low on time by the time I finished it. Right, we're there. That should now draw a little Bart Simpson dude on the screen. He's going to be black though. And we've got no code to keep his ink. So I'm not sure what's going to happen. Oh, hang on. Oh, bitmaps under it now. If you get that error I just got, you want to go right to near the bottom of your file. I'm pretty sure you don't need to tab this one, but I do. I just tab it. Use single quote. I think you can use either again, I'm not sure though. Util. This is how I've got it set up anyway, at least. There's nothing stopping you writing them functions just in this main file. It doesn't matter, and then you don't need to do any of this. But this is just one way I know to keep my folders tidy, and I reuse these, as you can see. Alright, so that's all self-explanatory, I hope. If not, let me know in the comments on YouTube, and I'm happy to help you. It should compile. No. Oh, I've used calculate cells. I forgot to mention that. The only reason is that I didn't mention this is because we can comment it out for now. It's to do with the colours, but I'll explain more in a second. Oh, maximum X is not defined. You know what? Copy and load of the fields and constants as well. I'm just deleting these two that I've already written because I copied them in again. But, these are just left. I haven't used half of these. I've just put them there for my own use in games. I'm going to start copying and pasting a lot more. There you can see the calculation. It's done at compile time, so that I've used any math I want, and Pasmo is dealing with it. Should compile now. Yeah. Oh, I've still got the halt statements in there. Don't want that. All right, yeah, we've got a sprite there, but he's not being drawn correctly, and obviously his colours not working either. I done it the reverse way round when I made the code, where I drew the sprite first and coloured him. Anyway, I think we'll be able to sort this out. I'll just tidy that bit up. I'm going to uncomment this. That is in our move function. Move player. Alright, we haven't written this yet. But we're going to right now. Do it right at the bottom. No reason why not. Calculate cells X, Y. I haven't commented this code whatsoever because I was in a rush when I wrote it. But it's similar sort of stuff. What this is going to do, this is going to get complicated. It's going to divide our pixel value, which we've just put into A for X. It's going to divide it by 8. You can tab it like this. Now, these are actually stuff you've seen before. They might not be the exact ones you've seen, but they're rolling bits. And look on Z80 Heaven, which I've described many a time. It's such a good site. So I just write Z80 Heaven SLA. Tells you just exactly about it. My internet's running really slow, so I hope the stream's alright. It looks alright on the stats. Okay, we're there. It doesn't actually tell you what it does. It's odd. Normally it would on this. Yeah. It's moving the bits left 1 in C, which is our which is weird because that's multiplying it surely. But I've got a lot of help with this function as well. But that's what that's doing. It's rotating the bits C left. I think we're just using that for the carry to check something. Anyway, when the carry is set, again, this is explained really well on Z80 Heaven arithmetic. If you Google that, and sometimes you just have to use these things. You don't have to understand literally everything about it. What I've done there with the $sign is a quick way to jump without a label. So that will go 4, that will go all the way to here, and that goes back 8 from this point, which is right there. Again, if you're a beginner like myself, it took me a long time to write this function, a lot of trial and error. You're welcome just to copy it and use it, you know, and then obviously adapt it to your own stuff eventually. So we completed the X part of that there. We're now moving on to the Y, pretty much doing the same thing. I'm aware I've made a constant for everything else and I haven't for that, but it's because I was struggling around. This doesn't want a constant. It makes sense to just have it written like as a number for that and that, but these could be constants for like bytes per pixel, pixels per byte, or characters. So, but it's 8's fine. I notice I have done it differently here. Well, it works anyway. I've tested it, so let's continue. We're pretty much doing the same thing. JR is like jump, but jump's relative. So you can only have a maximum size of a jump. It's actually slower than doing jump, but I think it uses less memory or something. I don't know. Just notice we haven't declared those. Player cell X and player cell Y. Long story short, it divides it by 8 and puts the new value in there. So it divides that and it divides that. It doesn't even need commenting. Or gets caches player cell values. That'll do. Yeah, that's what I know, mate. But trust me, this works. I got it off of a website. It's odd. I don't know how, but that's what it's doing, isn't it? It's taking the pixel value, turning it into 8, dividing it by 8. I can't get my head around how it's working now. The other day when I went through it myself on my own, I did understand it by the end of it, or I thought I did. But I've got a copy here written that does work, so and I'm copying it, and I triple checked that because I thought the same thing myself. Left would multiply it, but I think that's something to do with the carry. That's all we're worried about is how the carry flag's affected. So that's the C register, yeah, but that's the carry flag. Two different C's. Yeah, I got it off a really in-depth because I tried to use another method of division, but of course player X is a word. It's a 2-byte number, and I had problems, and that's what led me to find this solution online. It's flipping weird, but I obviously don't want to mess with it and start making it rolling it right. That's what I started to try and do in the first place with my own written function, and it didn't draw all the colours in the right place. If we assume that that's calculating the cells correctly, it can stay there. Something's wrong with the draw player as well, but I think maybe I just copied not enough lines or something. Although it looks like I have copied enough lines. But let's worry about the colours, because that's the main focus of this one. Exactly, yeah. Like I know at worst case scenario I could probably just copy and paste I mean it's on GitHub already, the working one. So this is just sort of, I went trying to go through it step by step, but it might fail. We'll see. I mean, I managed to do all this in one morning. It wasn't like I've been at this for weeks. I'm just copying and pasting what I've done this morning, other than the Y2 picks method and all that. The last remaining functional routine left is the paint player routine. It's only about 30 lines, so let's get started on that one. I think I'll put that, why not right at the bottom? Now this one requires no inputs other than we'll have it stated down here what colour we want for the player. It's a constant. That's just yellow ink. And of course if I don't mask this, it's going to make sure that it's black paper, which is not what we want. And now we're getting to the nitty gritty of what I was actually asked about, which was painting our sprite, because we pretty much there got the same stuff we've already written. That's kind of new because we didn't need to know the character cell before. So paint player, I'm going to just double check my notes. Yeah, no inputs other than that. We know the starting addresses, the memory for the color. Alright, yeah, this is how I did it. So OX58 is this equals start of color attribute memory. Formula is just like a standard array, a 2D array. So correct attribute address equals OX 5800 plus Y times 32 plus X times 1. And there you have it. It's as simple as that, but unfortunately on the Z80 and most of these old processors, as far as I know, you can't do multiplication and you can't deal with 16-bit numbers properly. So obviously you can. This is where I've spent all morning figuring out. But here's one way of doing it, which is what I've done. I doubt highly that this is the most optimal way. By the way, this is a beginner's sort of hack at how to do it. But I loaded H with 0 just to ensure it's 0, because HL is a 16-bit register and I'm going to be using that. So then I'm loading A with the data of player cell Y, and that will always be an 8-bit number. L is now equal to A, so that means HL equals player cell Y. Obvious, right? This is my lame approach at how I did it, but it ended up working. 2, 4, 8, 16, 32. So that's that part checked off. Going to do a similar thing, but of course a different thing as well, that's why we had to write this function to get it down to that, because I only had it in pixels at that time. So we've already got that there. Again, D0 just because we're using the 16 bits and we're just only going to load the lower bit. So I'm just ensuring that it is 0. May not even be needed. So now DE equals A. Don't know whether to comment that or not. I don't think I should, because I don't want to sort of swamp the comments. So now H equals that. DE is no longer in use, so we'll use that again with the base memory address. I mean, I should use my constant really, should I? Excuse me. Add obviously HL with DE. So now we have the full formula done in HL. Let's copy that. We'll now load A, which was not in use, with our yellow ink byte. We're aware that we've got to be careful about drawing a new background color or paper color to the same memory address. Just double checking what I'm doing here so I can commentate. I've written some weird note here. I'm going to write what I wrote and then I'll try and make sense of it. At this stage I think I was in a rush. It's quite possible the note is rubbish. Oh, nah, that's straightforward. Oh, did you figure it out, Baker, did you? Nice job. Yeah, I mean, at one point I thought I figured it out, and that's obviously how it ended up on the page that I wrote, but now looking at that division thing, I'm baffled by it. But you don't have to understand everything to use it, do you? Back to this exact line, what I've done is I've just pulled the existing byte of attribute data into E. And then what I'm doing is using OR E, which compares E with A and does a bitwise operation OR on it. So basically, the paper values, because we know that the paper values are 0 here, where is it? Yeah, because of that, because of the way OR works, and look at Z80 Heaven or my videos if you don't know what that is, but the way it works is if there's a 1 in E, it's going to remain that way. So that's exactly what we want. But if there's these 1s, it's going to always result in that 1. Likewise, we already know it's 0 because we've never set the ink to anything other than 0. I wonder if I should comment that. I think that says it all really there. So A has now been fixed to our desired bits for the whole byte, and we've set it into the square. But because there's 1 next to it that we have to deal with as well, so we do the similar thing that we did before. In fact, we're doing the exact same thing there, but we're doing the same thing we did earlier on in the session, where we're just moving 1 to the right and painting it again. Make sure I'm in the right area. And then we decrease HL again, or decrement, because I just went forward 1, because what we're going to do now is it's really straightforward in color memory. We were in pixels before when we were messing around with this, but we can just load it by 32, that's how many characters there are in a line, and increment it by that instead. You can't just write add HL32, the processor can't handle that, so you have to do it like that. I'm just clicking my notepad so I make sure I don't lose track of where I am, because there's a lot of repetition. Basically, there's luckily only 4 squares, isn't there, for us in our 16 by 16 bitmap, sorry. But we've done 2 of them already, and we've actually just moved down to the next one. We've loaded A with the correct thing. We're now going to do the same with E. Grab the existing one, use OR on it, load HL with A now. That's the 3rd bit, or 1 1 in the grid, or 1 0 I should say, or 0 1 X first. 0 1 in the grid is now done. So we ink HL. Do the same again. So a lot of repetition, but actually it results in some quite quick sprite drawing and painting code, which is what we want. I mean, this is nothing like the code I've written in any of the C languages that I've worked in, or Java or anything. I hope that made sense to you. We skipped. Oh, thank you very much for the follow, Muskie. I actually noticed one as it came in. Oh, Anarchia, thank you, man. I'm sorry I missed that. Wow, the coding's really popping off for me. I've got to make sure I do more of it. I hope this made sense to everyone. We skipped. We've got this bitmap here. This one represents a color cell. So there's that one. We started from there. We inked. Then we had to decrement, and then we inked by 32, and we ended up here. And then we inked, and that's it. It's that simple. That bit of the function is actually very straightforward, but we did have to back it up with a bit of messing around, caching these values. That was where the muscle work was done. I'm fairly confident this will work now, and we'll have a sort of Bart Simpson running around in a random hodgepodge world. Oh, the amount of times I do that. Okay, save the file, compile. Oh, here we go. We do have a problem. Calculate cells XY is undefined. That's because I called it calculate cells, I think. Oh no. Oh, cell. There we go. Yeah, it's compiled. Okay, he's not yellow though. There are some problems here. Let me figure this out a second. What I missed. Oh, noob mistake, like I always make. Almost every project I make this mistake. I didn't call the function. Called paint player. That's all we need. Yeah, what I did was I decided in the move function that was an apt place to call calculate cells. That should have really been called like cache cell values, because it's actually saving the value into our bit of data down here that we've set aside. One of these here. So it's not brilliantly named, but that doesn't matter. I'm quite confident this should work, and it has. The drawing needs some work, but again, go and look at my other videos. It just needs a small tweak. This lesson isn't about zoom that in. This lesson isn't about fixing that sprite there. It's something quite straightforward with the draw code, but it's actually about colouring them different cells. There's 4 cells there. Try and line it up. Yeah, as you can see. There's 4 cells, and he paints. You do see some glitches like that where he crosses a cell and it doesn't paint. But I think that's quite common on Spectrum. There's something called double buffering, which I'm going to explore myself. Never done it yet, but that's one of the next challenges for myself to do. And then obviously once I've learned that, I'll be sharing it here. But I got asked specifically to do this lesson about colouring my sprites, because I never bothered last time. It's just all black and white. It's not perfect. To be honest, the one I had before ran better. Like it, maybe I should copy and... Well, it's available on GitHub. Yeah, thanks, Moz. I'm glad you're still here, man. Thank you. I really hope it works out and you make your own project at some point using some of this knowledge. Definitely, man. Eventually, I'm going to go on to the 650 because it's got the Commodore has a sprite like hardware and a load of routines, so I'm interested to see how they work. Never done with the Spectrum. You have to write absolutely everything yourself, don't you? So, but I'm not going to stop on the Spectrum yet. I'm going to get us a nice looking like basic game of some kind that's complete before we finish the series. Hey, you won't be coding live. But even if you make a nice project and use any of this little snippets of code, I'd be happy with how it's gone, I've noticed they are my most popular videos. I've just earned 2 brand new followers, so thank you again to those. Maybe 3 even. And I think I'll leave it here for now on that one, because I'll just be rambling on and on otherwise. It's the middle of the night as well, isn't it? But I'm going back to my beginner series soon, where I'm taking it step by step through 2 different books that I worked through. It taught me a lot, so I'm trying to do each chapter of the book really as its own video, and also, but I am putting my own spin on it. None of the code matches what you'll see in the book, but yeah, I've really enjoyed it. I hope you have. I'm really glad you've stuck with me this time. It's made me feel a lot better. At some points, it feels like you're talking to yourself, So yeah. Have a great night, guys. I'm actually going to probably come back for a little gaming session. I don't know what yet. I'll have a think. It's not going to be a super late one, but thanks, Moz. Your comments and everyone else's comments are keeping me going on this project, of the whole video project. I mean, I'm quite happy at home. I've been sat at home on my own coding for a long time, and I could easily slip back to doing that, but I'm enjoying the videos, especially with you guys around. So yeah, I might get some pirates on. I'm gonna have a look, something a bit fun that I can just smash out for an hour or something. Catch you soon, guys. Check me out on YouTube and give me a subscribe there as well. Much appreciated. See you again soon.